quite a bit of stuff in a real short period of time. And I'm going to be talking a little bit about DFM. And for some of you, that may not mean a heck of a lot, but a long time ago, it was a really big deal. Design for Manufacturability, or DFM, actually is a trademark that Monroe had for a long time. We still have it, but we don't enforce it. We were kind of like the first on the block using that term. I'm going to talk a little bit about manufacturing and stuff like that, but first what I'm going to do is give you a little insight on what Monroe does. This normally has music, but you can hum. Anyway, this is kind of everything that we do in 30 seconds. Everything you see on the walls, and anything you see on the screen, I should say, are things that we've had something to do with. And it all has to do with design for manufacturability. It doesn't matter whether it's a car or a missile, it doesn't matter whether it's an airplane or a medical device, it doesn't matter whether it's high or low volume. Manufacturing is what's going to bring the economy back, and it's going to make everyone here in the United States a lot wealthier. Hopefully. If we don't get on the bandwagon for manufacturing, we will lose out. And we've already had a kick at that cat. It wasn't a whole lot of fun, so I highly recommend we don't do it again. We have a mission at Monroe Associates. Let me do something else. See that little thing there, that triangle? Looks like it's sitting on its ear. That's really not a triangle sitting on its ear. It's a less than symbol. For years, like since 1983, that is what we wanted to do, get less than. I want less parts. I want less fixtures. I want less steps. I want less manpower. I want less of everything. And the reason for that is because you get more. The more you can pull out of the design, the luckier you're going to be at the end of the day with profitability. We also found out that to the customer, you're going to see better value and better quality. So the three things we've got up there are quality, value, and profit. And that's kind of like what our mission is. Our mission is to help customers consistently maximize product value, quality, and profit. Because a profitable company will survive, and the other ones will go by the wayside. The other thing that we are is we're in the business of innovation. We have a lot of titles, but that one was given to us by the people over at NASA. NASA calls us an innovation factory. That innovation factory approach is kind of like what we kind of got into, and we've been doing that for a long time. So that's the end of the commercials. So now what we do is going to talk a little bit about who I am. Okay, so I saw some pictures up there, and there was generation this and generation that, and baby boomers. Shit, I got left out. I'm even older than that. But I was very lucky. I was around before all the acronyms. I was there when they were invented in many of the cases. All the other pioneers that came up with this stuff, they're either dead or wearing a drool cup. So sometimes it's a good idea to find out what happened and who did what. And that's why I thought I had a totally different presentation until I talked to Peter and he wanted to do that little videotape. And it started to dawn on me, nobody knows any of these stories, so you can carry them on or you can forget them. But in the mid-'80s, or in the early '80s, something came out called DFA. It wasn't designed for assembly. It was called Design for Automation. We wanted to robotize everything. Later on, it became Design for Assembly. After I left Ford, I'm not getting into that story, but after I left Ford, I couldn't use DFA. The guys that owned it were very litigious. So I kind of called it Design for Manufacturing because really and truly, assembly was only one aspect. Then there was statistical process control, TPS, the Toyota Production System, TQMS, all of these different acronyms came up, but the one thing that we can always count on as being the real big problem was the dreaded enemy of progress, which was the finance guys. Those guys always held us back. There were also a whole bunch of different kinds of people doing different types of jobs. Product design engineers, manufacturing engineers, industrial engineers, quality engineers, and a tremendous number of other engineers. But then, of course, there was the big enemy of progress, those finance guys. And I'll get back to that as we move along. This is kind of a chronology of everything that happened. From the 40s until the 90s and into today, it really doesn't matter because this is kind of like how everything got going. So you see Deming getting fired by Ford Motor Company because the Wood kids didn't like him. and you see Deming going over to Japan and turning them into a powerhouse of quality, and they basically still really and truly dominate the marketplace using those philosophies. Dr. Ono, Shingo, all these different guys pumped in information into Ford Motor Company, and I got to be the recipient. Lucky for me, everybody at Ford was old except me. I just kind of like, I'm glad that it's there. So I got to be the repository of a lot of different things. And in fact, Dr. Deming was the guy who convinced me to go into business. I knew all of these people firsthand. I got training from them firsthand. And they say that the further you get away from the spring, the more polluted the water is. Well, luckily I got it right from the source, right from the horse's mouth, as it were. So we worked on a lot of things, but one of the things that we worked on where all the stuff came together was the torques. And I'm going to show you a little story of what happens when one company is using one way of thinking and another company is totally behind the 8 ball, okay? Totally left behind. In fact, I'm going to show it to you twice. Because everything that changes, it just becomes the same again. I've seen enough of these cycles to know that what one company had in the way of profound knowledge, something that should have allowed them to dominate the marketplace, gets forgotten. And then somebody else rises up. It's like a great big sine curve. It's amazing. It's amazing how incredibly stupid we are in learning and forgetting the same rules and regulations over and over again. So anyways, like I said, Dr. Deming got me to start Monroe Associates. For those of you who don't know Dr. Deming, he was the master. He saved Ford Motor Company, among other things. He was a brilliant guy. He was also outspoken. That would be the kindest word that I can think of. When you get into a big meeting and he points at the chief executive officer and he says, "Well, Sandy, you're going to get out of here, you're going to become just like him, stupid as a stump." And you know what? That's a career ender. So he helped me get out of Ford. The things that, when we started the company, I had 3 premises. One was from Dr. Deming. As variation is reduced, quality will increase. And quite frankly, where's the best place to get rid of variation? Well, that would be probably in the product design. How do I get rid of variation? Attack the design. Don't go out on the factory floor and do Six Sigma. We do it. Customers ask us for it. We'll do it for them. But the problem is, it's already a mistake. Now I'm going to be throwing out investment tooling. I'm going to be retraining people. I'm going to have a product in the marketplace that's going to have to stumble before we can catch up. It's like dumb. Do it right the first time. And then the last one is, I'm sure as you grow older, some guys are old in here. I'm looking around. Oh, you're really old over here. So anyways, as you grow older, you'll find out that there's a lot of people that I kindly call bullshit artists, and there are plenty. And this is where you separate the bullshit from the buckwheat, and that's it right there. It came to us from a guy a long time ago, Isaac Newton. He says, if you have no numbers to support your theories, you don't know what you're talking about. That's the great differentiator. So those 3 premises is what we built the whole company on. Then, and this. This was something that if you type in shadow diagram, this will pop up. For a long time, I tried to hang on to this, but it's impossible. Just like owning DFM, who cares? You're never going to be able to inflict any punishment or get any big royalties. It doesn't work. Same as this slide right here. I like to keep it, like I'd like to have people leave my name still on it, but I'm telling you what, if you type in shadow diagram into Google, that is what's going to pop up. That was created in 1983. It was created in 1983 because I moved from, I was a manufacturing engineer, then I wanted to be a product design engineer, and then I got moved into finance staff because the tool that we invented was making so much money they didn't think that I should be in engineering, because engineering is not supposed to know about profit or loss or how much things cost. The finance guys, they pulled me in, and I didn't know, I really didn't know anything about finance, and basically I was alone a lot in that place. But what they asked me to do was to find out, how do we become more profitable? So the bottom right here was what we started out with. What were the costs associated with any kind of a product over the life of that product? 5% was product design, 50% was material, labor was 15%, and overhead was 30%. Okay? So, what did Ford do when they had problems? Well, squeeze suppliers, right? Fire laborers or replace them with iron workers like robots. And then if they couldn't get the plant manager to do his job, then they fire him. And and this is no lie, 3 times in a row firing a plant manager, you level the factory. That's kind of like what they did at Ford. But that had nothing to do with the influence over profitability. The buildings we found were plus or minus 5. Labor didn't matter whether the most militant or the most benign unions. It didn't matter. It didn't make that much difference. The supply community. Okay, now a lot of people are young. You might not remember this, but there was this car called an Explorer, and it used to roll over a lot. And a lot of people figured it was because of the tires. That's the kind of impact statement that we were looking at when we did this chart when I was at finance staff. What happens if a supplier really screws up? And that was the 20% influence. And then 5% is over here. Nobody cares, right? Who cares about engineering? It's only 5%. I've always found that if you want to find the weak link, look at the things that at least initially appear to be insignificant. Bet you dollars to donuts. That's where your big problem is going to be. And that, if you attack that one little geeky area, you'll make a big impact. Same here. 70% of our ability to make money, 70% was in the design. After that, it meant nothing. If you've got a lousy design, you will die in the marketplace, period. And by the way, I should tell you, the people at Ford Motor Company did not like that slide. Red Poling, who was the president at the time, called me names, called my mother names. Didn't even know he knew my mother, but he called her names too. He really didn't like this slide because he was under the impression that the greatest force inside the company was finance. Accounting and finance. This is what came out in about the 1990s. Now it says the tourist shock on there. That's because this is kind of what the guys at Toyota called the tourist shock. They were scared to death, and this whole presentation is something that I use when I talk to the people at Toyota. This though is a Grand Prix bumper. I want you to have a look at it. It looks fairly complicated, but it has a lot to do. It has to have a 5-mile-an-hour bump, that no appreciable damage. It has to have the ability to protect the back rear seat occupants in the case of a crash at 30 miles an hour. And it has to look nice, okay? Well, it looks nice, and it does its function well, but compared to something else, maybe it's not so good. So what I want you to do is I want you to look at this product, and I want you to try and, in your mind, exclude this part right here, because this part is not in the other design. That's called a license plate illuminator, and it's not in the other design. So we'll try and, mentally see if there's any differences based on that thing being missing. So I want you to look at that, and then look at this. Anybody see a difference? Let me show you again. That's number 1. And that's the competition. Now, it does have this one little trick thing in back of it, okay, called a EA shock. That's General Motors, and that's Ford. How do you compete? Let's look at all the ramifications associated with this thing. Number 1, the attitude in the 80s and early 90s toward manufacturing was, as long as it does everything the customer wants, engineering has done its job, and they can throw the drawings into the sea of manufacturing and somebody will figure it out, right? It's manufacturing's problem now. Some people call it the over-the-wall syndrome, whatever. It's manufacturing's problem, not our problem. This is what it looks like when you put it into simple words. There are 104 parts inside the Grand Prix and 15 parts inside the Taurus. 15 operators were needed to build the Grand Prix. 2 operators were needed to build the Taurus. Let's have a look at the line itself, okay? Because investment is always a big thing. That's a GM front bumper line. $17.2 million, 8,400 square feet to build that bumper line. There's the Ford line, $2.1 million and 800 square feet. Now, I have to give an acknowledgement. These slides were not made by me. They were made by General Motors when they were trying to convince their people that maybe, just maybe, there was a small problem that needed to be addressed. Hard to believe, but it's absolutely 100% true. Now, Ford had the world by the string, right? Everything was wonderful. Everybody loved Ford for a long time, and then they took a nosedive. What happened? What happened was they decided to move back and do the same old silly things that they always did. They got rid of the technical people and brought in the bureaucratic people in the hopes that somehow, financially, or using finance people, they could squeeze more profit out of the product. And they lost a lot of market share. A lot of people don't think it was the tires that caused those cars to flip over. I don't know, I wasn't involved. But a lot of people thought that maybe it was because of the squeezing that was done at Ford to make things happen. So, let's look at this. This is the 1915, I forgot that guy's name that has the big auctions and whatnot. Anyway, they had the 2015 first Mustang 50th anniversary vehicle out there, and they raised $170,000 for charity. That's pretty good, eh? Well, we don't work for Ford very much. We have Bentley and we have Volkswagen, and we do work with BMW, and we worked on the Mini. We did a lot of stuff on the Mini. But right now, our biggest customer is Chrysler. And this guy from Chrysler, a vice president, said, Monroe's lean design workshops and competitive benchmarking contributed to a 25% reduction in engineered hours per vehicles. That's not really hours. This doesn't include things like walk time or fetching tools or even picking the parts out of the parts bin. It's only the time it takes to put the part into the product, and then magically a tool runs the product down. It's a way of levelizing plants. So 25% really equates to around 40% reduction in labor. And here's what kind of happens when you think differently than competition. This is the $1.6 million car, the Hellcat. That was number 1. It was sold for $825,000, but they wound up with $1.6 million because there was matching funds. That's a small indicator. If you don't connect the dots, it doesn't mean a heck of a lot, but when you connect the dots, it starts to say, hey, maybe there's something going on with this little dinky company. So let's look at, these are the August numbers for sales. Okay, so there's General Motors, minus 1.2%. There's Ford at 0.4%. There's Toyota at 6.3%. Let's look at Chrysler. That's 19.8%. They've had double-digit growth every month for the last 4 years. From a company that was literally bankrupt to rolling in cash. So, now, thanks to my wonderful little phone here, or communication device, because it's not really a phone anymore, I just found out that Chrysler stock goes on sale on Monday. Here's a tip. Maybe it's an inside tip, I'm not sure, because I am on the inside, but I think if you got some loose change, you might want to think about buying some of that. By the way, let's look at the rest of these guys here. Honda, 0.4%, Kia, 5.5%, Nissan, 11.5%, Volkswagen, minus 12.8%. That might have something to do with quality. How many people here own a Volkswagen? You don't have to really put up your hands. I sympathize with you. When I was a kid, when I was very young, and they put them in strings and hang them all over the vehicles. I haven't seen that in 50 years. Guess what? There's one on Coolidge Highway, sitting on the side of the road with lemons all the way around it. They're having a lot of problems with Volkswagen, so it'd be a good idea if you consider something else. Anyway, down in the bottom they've got the total, so the average, if you look at everything, everything went up 11.1%. Anybody that's below that is a problem. Anybody above that is killing the marketplace, and it's not because of cost, it's because the product has value. Okay, so cars seem to work on things like this, and like I say, if you don't forget the problems, or let me rephrase that, if you don't forget the rules that it takes to get you where you need to get to, you probably won't have a problem later on. So let's look what happens when you start looking at things that go boom. So this is a Stryker tank, okay, and the Stryker tank actually was invented or came from Sweden, and it's been around a long, long time. I worked on that tank when I was in my 20s, manufacturing it, and I didn't know then, but I do know now, that it never was able to fire 11 rounds, ever. You couldn't make it happen. So think way, 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 way back into the 70s, and this thing didn't work. So now we want to take them and put them in Afghanistan and Iraq. A little bit of an issue if you get into battle and you fire one round and then the thing jams and you have to turn tail and run. People feel uncomfortable when you do that. Not the enemy so much, but the guys in the tank. By using design for manufacturability, maybe in a little higher elevated form, we managed to find out things, and this is a nice little thank you letter that I'm going to blow up a bit. And it says, as I write to you, the Stryker is en route for the first time to support the soldiers during Iraqi freedom. I wish your team continued success in the future. Okay, think about it. 50 years that tank hasn't been able to be used, and if you use the right methodology, we figured out how to fix it, build the products that needed to be put into the place, and in 4 months, take it down to the test center at Aberdeen Proving Grounds, and after 3 cracks, we hit 11, and then after that, it never jammed again. We have the ability to design and manufacture almost anything, but to do it so that it's got a profit, and to do it so that it actually works, and to do it so that people can actually put it together, that's the trick. And that's kind of like what we need to focus our attentions on. But it has to happen as early as we can possibly get in. Now normally I carry a whole bunch of stuff with me, and this is usually one of the things, but unfortunately I'm going to China tomorrow, and I'm not going to be hanging around here too much today. In fact, I came in thanks to my trusty pilot, Sid Siddiqui. I don't know where he is, but anyway, Sid, there he is in the back. Sid has a light plane, and he flew me from Detroit, and as soon as I'm done flying back, so I can get on a plane and go someplace else. But the thing is, this, in person, is kind of more imposing than just seeing a picture. But that is the time, that's the time that you want to start fooling around with manufacturability. Somebody sketches it up. At that moment in time, we were looking at things like, oh, how do we add more functions? How do we add more features? What are we going to do to make the consumer delighted? What are we going to do to tear away the competition? How are we going to tear their fingers away from that market share? They're not going to go easy. We have to have something that's brilliant. Okay? Here was what we came up with. That's the sketch. And by the way, I have that sketch. And it is literally on a napkin. For real. It's on a real napkin. That napkin sketch got us into this thing over here. And the one thing good about this was it allowed us to do something called neonatal. I can slap that onto a baby and it won't die. Whereas the old versions, you signed a little waiver. And I know that for sure because my son used to get sick all the time. And if we took him to the hospital, you signed that little piece of paper. He's got a temperature of 104 or 105. He's going into convulsions, and they say, well, we can't tell you whether you're going to live or not, but if you don't sign this, we can't scrap. That was tough. This made all that stuff go away. They went from a minor market share to market domination. They made that happen in half the amount of development time that it would normally take. Half. Why? Because we looked at the design and looked at it hard and made sure everything was right and made sure everything was right the first time. Right first time is really and truly what design for manufacturability is all about. There's the old one, that thing on the side, and that's the new one. So what kind of impact? 575 parts down to less than 130, 100 fasteners down to 30, 8 hours of test time down to 2 hours, actual throughput 8 days to a half a day, 4 hours. Size went from whatever to whatever, but the weight. This is what we really made the nurses happy. Who the heck wants to lug around something that weighs 14.3 pounds? Let's drop it. Let's drop it quick, and getting it down to 6 pounds was a big deal. The nurses loved that sort of stuff. The real objective behind anything DFM is to mitigate risk. Nothing, absolutely nothing, will send your investors skedaddling to the woods faster than if you haven't got a risk answer. If you don't have a risk answer, you will not have an investor. They will go away. So how do I mitigate the manufacturing risks, the quality risks, the financial risks, all the other things that are going down there? The only way you can do it is with a holistic approach. And a holistic approach has to start with the very first pencil on paper, or pixel, if you happen to be using AutoCAD, pixel on the screen. You have to make sure that you're going to start looking at everything, not just the function. Function is easy. Any moron can make something work. How do I make it so that it's going to work and make me money at the same time? How am I going to make it so that it works and actually is attractive to the people in the marketplace? And a classic example is BlackBerry. They had something that worked. What happened? They dominated the market. What happened? How do you lose a market that size so fast? Overnight, they went out of business. How do you do that? That's what they call in Japan American arrogance. Where there's arrogance, there's opportunity. So as you develop your products, make sure that you take a holistic approach. And when I get into talking about additive manufacturing, I'm going to talk about one of the risks that you definitely need to think about. Okay, so let's look at other things that are sitting out there in the marketplace. Not everybody is going to make cell phones, or iPhones, or the coolest new software, or whatever. Some people are going to make ships, and that's what this is. Have a look at that thing on the left-hand side. That has been around, you know the building analogy that was just talked about? They haven't really improved ships much since the Ark. It's really amazing when you get inside and you look at the sweat labor that has to go into manufacturing product and how little has been brought into the shipbuilding industry. That thing on the left was their attempt at something amazing and new. That little thing down below, that little teeny pump, does exactly the same thing. The only difference is it costs a lot less and it works a lot better. So I showed you some of that other stuff, but what I didn't show you before was the financial end. These are the kinds of things that you have to look at if you're looking at a holistic approach. Okay? You have to look at the manufacturing readiness level. How many people here know what that is? Manufacturing, MRL, manufacturing. Not a heck of a lot if you're going to be in manufacturing. If you can't provide a manufacturing level of at least 8 or 7 or 8, you're going to have a big time problem. It just isn't going to work for you. Manufacturing readiness level is extremely important. Technology level is good, but if you can't manufacture it, it doesn't matter how good the technology is. The serviceability readiness, I'm not going to go through all these things, but the next one down is the producibility index. Knowing at the beginning of a program that you're going to be able to produce a product, that's what's going to appeal to investors. You have to be able to somehow tell them that, hey, when we get this all done, it's going to work like a charm. Confidence index. Confidence that your specifications, your ideas of what the customer is going to actually want and actually been addressed and are going to actually come out the door after you start producing the product. All these other things, parts and steps and whatnot, that stuff goes through, but let's go down to piece cost. I'm talking about how do you find out what the piece cost is at the sketch stage? I need to know that. Your investors will need to know how much is this going to cost when you're showing your concept. Showing them the first part, you can maybe extrapolate backwards, but until you actually know exactly what it's going to cost, it's going to be hard to get investors on board. So if we look at this, the labor cost, the part cost, the quality burden, every operation, every step, every part, every process, everyone, they all have a PPM rate. It's based on history, whether it's plastic injection molding, or bending tin, or growing crystals. It doesn't matter what it is, eventually you're going to have a bad one. Not everything is Six Sigma. And if you think along a holistic line, you're never going to be able to get to where you want to get to unless you know where the traps are, where the pitfalls are. For instance, threaded fasteners. I can either have a Six Sigma, I can have 3 bad parts in a million, or I can have about 150,000 bad parts in a million. And that will ruin your reputation in the marketplace. So it's a good idea to find out everything you can about your product. And what we found it best to do is to fix a cost based on what happens when you screw up or when something goes wrong inside that product. Then you can get a total cost that actually means something. And if you look at this, it went from $50,000 down to $9,000. That's an 81% reduction in cost. That's what kind of makes things happen. When you want to get into something, it's going to be always how cheaply or how inexpensively can I produce a high quality product that's going to have a great deal of interest from the persons that are going to be buying your product. Then you start going into NRE and whatnot. This is the kind of thing, though, that you need to do. You have to have this in the way of a business case, and you have to get it relatively early. And quite frankly, this is kind of like what we do. We don't sell AutoCAD. We sell something that gives you these kind of numbers. And I should mention, too, before I forget, my associate, I've taken off, but my associate, Dave Loic, is right there. And so he can help you out if you're interested. It's also a good idea to have a strategy. Now, there's a thing on our website, it's about 12 minutes long, and if you want to find out how we do new product development with Chrysler, or with shipbuilders, or airplane guys, or whatever, it's on there. You can download it and do it yourself. It's not that tough if you have the rigor and you have some tools. You can make it all work. That's kind of confusing, but if you, like I say, go to the website and download that video, it doesn't take long to figure out how things are going. So what's next in the world of DFM? Well, we're embarking on a new way of thinking. We're changing minds, and we're creating impossible designs. Okay, minds and designs is kind of like that's really cool stuff, because some of you may work for a big company, and changing the minds of the boss makes a big difference. I watch great ideas die all the time. They died because the boss didn't want it. So here's a new word for you. It's a psychological word. I don't know how many of you guys are engineers, but I know when I went to engineering school, I had the option of taking different courses. And you know what courses I never took? I never took any humanities. What in the world for? Maybe that's why I never had any dates. I don't know. But I can tell you, it really didn't make any sense to me. Math, science, that's what I want. Psychology, you gotta be joking. It's all flake. Nope, it ain't. And there's one little word that I want you to go and look up. It's called scotoma. It's spelled S-C-O-T something or other. Anyway, I told you I was an engineer. Show me an engineer, I'll show you somebody who can't spell. So, anyway, additive manufacturing is a great idea, because it gets rid of that problem. By the way, that only means blind spot. And you know, I shouldn't just leave you. Here, let me give you an example. How many people here have ever done or experienced this? How many people here have a bench or a workbench or a kitchen or something? Okay, and you're very familiar with it. And you go to your workbench or your kitchen or whatever. I'll use a kitchen because everybody put their hand up when I said that. You go to your kitchen, you're looking around and you're going to cook something and you say, geez, what the hell's garlic salt? And you're looking around, it's not anywhere. It's supposed to be right here. It's not here. And so, what do you do? Well, you yell at your spouse because obviously he or she was the one who buttered this up and moved it. And so you say, in my case, Sue, where the heck's the garlic salt? Or whatever I was looking for. Oh, you mean this? And it's sitting right in front of you. And she picks it up and puts it in your face and you go, yes, thank you, honey. How many people have ever experienced that? That's scotoma. That's a physical part. It was sitting right in front of you. If it was a snake, it would have bit you. But you didn't see it. Okay, now you're going to bring your boss an idea. He can't touch it. Or she can't touch it. They can't feel it. They can't smell it or lick it. Okay? And you're going to try and put this across? And you can't find the garlic salt? I'm telling you what, it's really difficult. For those who haven't taken things like that, about scotoma and things like that, I highly recommend you look at it. This is where additive manufacturing made huge gains, and I'm going to show you an example in a second. Okay? This is a Ford battery case. This is one right here. Okay? This is rugged and manly. It's got steel and plastic and screws and all kinds of stuff. It's really, really rugged. There you go. You can pass that around. Nice and heavy, isn't it? Yes, it is. That's what makes it rugged. And when you pick up something like that and you say, oh, that's manly. Guys grunt when they pick that up. Okay? Now, let me show you what this looks like when you put it into our software. Okay? You see all those little things up there, those symbols and whatnot? They actually mean something. I'm not going to go into describing what they mean, but they mean things. When I'm trying to build it, this is kind of like what I'm going to need to do. See, this whole thing is all red except for that part. It's only one part here, and it's green. Anyone know what that means? That's exactly right. It's the only part that the customer values. She can actually do something you can't. She can read. Wow, that's cool. Okay, so that's the part that the customer values. But you know what? How do you get to that? How do you know which part the customer values? Well, what you need is this thing, see? This is what we call the part value challenge. I didn't invent this. This came from Miles and Gage. How many people know who they are? They invented value engineering during the Second World War. And what they did was they tried to fix things on the factory floor. And when they didn't work, they said, oh well, and they moved on. But you know what? They had two little teeny lines that basically said, boy, if we had our way, we'd try and figure out how to get rid of parts. And if the part didn't have to move, or it didn't have to be a fundamentally different material, maybe we could scrap that or change it or combine it or something, right? So we just took it. And then we went and found out all the things that are perfect for poor quality products. Fasteners of any kind, springs and belts. This came as a result of something that I was in when I was at Ford called the Sealing and Fastening. I was a co-captain of the Sealing and Fastening Task Force. Believe it or not, no one at Ford knew that if oil leaked out of your engine and went all over your floor, that was a bad thing. It was a very strange phenomenon. But from that, we found out that these were our enemies. So we take that one green thing and we say, oh, we're going to make one part. So the first thing that happens is that everybody says that's impossible. And this is the main reason that I like stereolithography, or additive manufacturing, or whatever you want to call it. I was on the buy team that started this out, and again, this isn't new. This came from the early 80s. The early 80s we started looking at this stuff. It's only now that it's gained some kind of recognition, but I'm telling you what, a lot of people waited and waited and waited and turned into dust trying to get their points across. This makes a big difference. Now, I don't hand this out. I know everybody was anxious to touch it, but I don't do that because, ta-da, I got the real McCoy right here. How did we sell this idea? Additive manufacturing. Changing minds, you can't beat this stuff. No one buys an idea. And most of the people that have money They can't read a drawing. They can't see an illustration. They don't understand what's going on until you hear. See, we have a testimony right here. That's light. Now, let's look at the $2.28 million in savings that they got after they had to go and change all the tooling. That's where the problem lies. You don't want to change the tooling. You want to get in as early as you can. So we look at this other thing. What does this mean? This is called a scrap map. It's called a scrap map. Who's got the first design in right now? It's in the back. Can you bring that up to the front? I just want to kind of show you where the problem was. I don't know how many people noticed it, but on this product right here, there's a stud that's supposed to go through that shiny bronze hole. And if you look at it, you can see that the holes don't line up. So when you shove it over the top of the stud, when you're trying to build a car, it scrapes off the threads. Nobody wants that. Nobody likes that. They want all the threads on there. This caused that scrap map. The scrap map basically said, you know what? You're never going to be able to make any money on this deal. So by going to a one-piece part, we've eliminated a lot of problems. So it took about 4 months to implement that thing. How long do you think it took to get it to the point where somebody would nod their head and allow, I can't remember what the investment cost was, $85,000. To allow the $85,000 to be released so that we could take a wild guess. How many months? 12. Oh, you've seen this presentation before. It took us a full year. Yes, a full year. A full year until we showed them this. See, that's why I don't give it to anybody, because it cracks. This made the difference. Putting your ideas forward, especially if you've got a boss, even if you have to buy one and put it in your basement, get it additive manufacturing unit. We have one, we're going to get quite a few more, but this is one where we were making a receiver for a receiver block for a gun, obviously. So, and then there's the other problem. I didn't introduce this properly, but you know, the one thing nice about additive manufacturing is I can make anything, okay? I can make an egg if I want to, as long as I use a machine. But what happens if I want to scale this? What happens if one day, like this customer right here, we start off making 5 a year or 10 a year, and then the customer comes along just like this. This is our customer, but their customer came along and said, we need 150,000 or something? 150,000 of these things a year. That's a lot of little machines trying to get things out, right? It's impossible. So they come to us with this thing here. You can't do this. You made an egg. When you're designing your product, if it works in stereolithography, it doesn't necessarily mean, or additive manufacturing, it doesn't necessarily mean that you're going to be able to scale that up. You have to think about scalability right from the beginning. And by the way, this is brand spanking new. We just got the drawings on this, but it's not the first one we've seen where the product was developed using additive manufacturing, then it became successful, and now you got to go back and redesign the whole thing, and then you got to retest it. In this case, it's a military device. It's going to cost a lot of money. So what's next? Okay, finance. Finance, that's the final frontier for every engineer. Okay, we at Monroe Associates for a long time have been generating software to help people reduce parts and improve quality and blah, 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 but it doesn't mean squat. Now, everybody, in fact, I think that probably by the end of the year, about 70% of our stuff is going to be, can you tell us how much it costs? Can you tell us how much we can reduce? Can you tell us what the investment is? So, the latest generation of what we're doing is taking what an engineer would know and turning it into very accurate costs. And doing it in 2 ways. one, with the product that you're designing or you have in production right now, and two, what's brand X's cost? Okay, now, we got very lucky. The EPA likes us. They gave us a lot of money to find out how they were going to get to 55 miles an hour, or sorry, 55 miles per gallon in your next generation car. We got that contract. We figured it out. We showed them what can happen if they put in new technologies, and we showed them how much it would kind of cost to the consumer, because that's what they were really worried about. We found out that yes, you can get to 55 miles per gallon, and you can do it with very little, in fact, no cost increase to the customer. Guess how the auto OEMs greeted that news? Well, wait a minute, we got this tooling here. We want to run this for another 45 years, otherwise my bonus will suffer. Okay, so the idea behind everything now is how much does it cost? You want to compete with China? China's trying to compete with Vietnam because labor isn't what you really want to look at. It's the total accounting cost that needs to be looked at. I don't know where I am for cost. Okay, I'll just skip this. This is something, but I'm going to stop there. We developed the club, I don't golf, but for you guys that do, we're the guys that gave you that vehicle. We did everything. So, and their market share went from 32% to 81%. And anyways, I'm going to skip this. This is just the future that I think we need to remember that nothing stays static. Keep reinventing DFM. It was never intended to be a static program. We need to remember that the past. Don't repeat the arrogant, stupid mistakes that other people did. Old guys like myself and him. So we need to look to ways to change the comfortable rules in order to compete with the worldwide. We still need to analyze. Don't think that somehow you can do this stuff in your head. I've been doing this for a long time. I use an analytical method. We need to figure out how to reduce everything. Every part, every step that can be eliminated, every piece of waste needs to go. We need to learn lessons from benchmarking. And I'm going to stop right there. And this is what we do for a living. So we do a lot of benchmarking. That's our innovation center. That's what it looks like inside. This is what a Jeep looks like when you tear it apart. That's what it looks like when it goes into the software. That's what we're doing right now, is the BMW i3. Dave's got some things there if you want to look at that. This is our other place, the Knowledge Center. It's 70,000 square feet. That's what it looks like inside. Chrysler is very serious about finding out what everybody else does, and that's actually 100% now their stuff. That's what happens when you want to look at seats. There's 35 vehicles in there, they rotate in and out, they understand every aspect of every car, everything down to the last half penny. It's amazing what can happen if you understand the competition. Another thing is Sun Tzu. I highly recommend you read Sun Tzu. He's the real genius for strategy, and he says, know your enemy, know yourself, win every battle. And this is the new one. I just signed the paperwork today. That's why I was late in getting here. That's our new facility, and same sort of a deal. Now, last one. Monroe Associates helps engineering and manufacturing empower their aspirations. And by the way, empty suits beware. Anyway, if you need anything, you can talk to Dave Lloyd, and I'm going to be around for a little while. And you know what I really like about this place? You can drink wine while you're having a presentation. I like that a lot. Thank you.